Okay, I see it.
Can you see my screen?
Yes, I can. Yes, I can.
So can you see my screen?
Yes, yes, yes.
Oh, okay. I'm gonna put you on speaker now. Acting up. Okay.
Ah, Mr. Khan, thank you for joining us. Jonathan's just starting his presentation.
All right. So I'm Jonathan Hernandez. Hi, Mr. Khan. This Data 698 final project is basically looking at New York City traffic fare levels and volume. So we can go to the next slide. So the introduction to this is that throughout NYC, as we all know, there are many bridges and tunnels to get around the city. However, throughout the years, traffic congestion has been quite a concern. And, several ideas all over the place have been proposed, MTA being one of them, of course. So one thing I wanted to do in this project was to take a data set or take data that shows the amount of traffic or vehicle volume on a particular for each particular NYC bridge and tunnel for a given year and date and time. And I basically want to append or pen some simulated fare prices and see how the traffic would behave as we kept increasing the prices and how much traffic would appear for these particular bridges and tunnels. Um, One of the approaches I want to use is a few machine learning regression algorithms. And then what I want to do, or the goal of this, is to see if there is a way to maximize fare usage, but also kind of minimize traffic congestion at the same time. Kind of a win-win for everyone, if you will. And so some literature review that was done is that I read some blogs and posts on a few sites, and some sites like streetsblog.org mention variable pricing at the bridges and tunnels would ease traffic by encouraging some drivers to alter their trips to off-peak times. A kind of shift and change like this would decrease traffic from about like 5 to 12%, give or take. And then other ideas that were mentioned in this article would be to, charge higher for like the peak hours and then charge less for the off-peak times to reduce that traffic congestion. Another site, shows that implementing New York City congestion pricing can also help to also improve the travel speeds. And then what they mention is one pricing model that you can either do a flat all day price and or you can do a low to moderate high peak period price. And then another site that I found that I probably found interesting is that Optimist.com says the MTA and the city have decided to apply congestion pricing in 2020 to 2021. That's good for everyone coming to New York City. And so some data sources in summary to get started. I was able to pull the data from a Kaggle site. Basically, in summary, it is a CSV file of bridge and tunnel tolls from the year 2010 to around June 2019. And what it does is that it shows how many vehicles went through either paying by cash or Easy Pass for each toll plaza on a particular date, and whether the traffic or the count was either for inbound or outbound traffic. One thing to note is that I noticed that the time in the date data set is measured per hour. So, like every 24 hours, it's a measurement that is done to collect how much traffic was done. And then that's kind of what goes on a per hourly basis. And then a little summary of the features in the description is we have a plaza ID that's kind of a numerical ID that represents each toll plaza or toll booth. So one thing is that, excuse me, numbers 1 through 11 are the original historical values before, I guess, the city decided to do tolling switchover dates. And then 21 to 30 are values after the road tolling switchover date on 2017. I'm not too sure why there was a tolling switchover date. And that's something I had to consider while doing my analysis as well. I had to kind of, do mappings and encoding. And then the date is the date of the measurement taken, hour associated with the data, the direction as mentioned previously. Is it either inbound traffic or outbound? The number of vehicles using an easy pass, and then finally the number of vehicles that paid in cold cash. Okay, and so a little bit of EDA. One thing I found pretty interesting in Python is that there's a module called pandas profiling that has a one-liner that could do all sorts of wonderful EDA. It can give you first row, last row correlation, missing values, outliers, extreme values, histograms. It's kind of like a Swiss Army knife that you can just do on the fly. So we see some of the first rows that are done here. Shows an example of the data set. So for example, we see in July 1st of 2020 at around 2 p.m. Eastern Standard, the Verrazano Narrows Bridge had roughly about 1,356 vehicles that were paid in cash, and about 3,600 that paid in via Easy Pass. So, and then continuing more in the exploratory data analysis, we see number of variables, cells, duplicate rows. The only thing about the duplicate rows, this function basically, there are no duplicate rows, it's just going by columns. So for one bridge, let's say you might have the column Plaza ID repeated, but it's different measurements taken at times. So I didn't pay much to the data set of duplicate rows. And then we can see here this Pearson's correlation is quite, everything's mostly positively correlated. So like the vehicles and the cash tolls are pretty highly correlated. Stuff like the hour of the measurement taken and the vehicle count, excuse me, has like kind of like some low correlation. And then something you may want to consider. And then a little short summary. There already are no missing values, which will make things easier in this analysis. As mentioned, there's positively skewed correlations. Also, there are no like extreme outliers, and I don't think they will affect the data and the results. So, and then what I had to do in order to append the fare prices, I had to do some research and see what were the toll prices and during the year 2000 or 2019. Looking around Wikipedia, you could find out for most of the bridges. I believe most of them, except for the Verrazano Narrows, the toll prices are like about $6.50 starting from 2010. The Verrazano Narrows was double, which is hence by this second column right here, the Verrazano Narrows Bridge. So I just loaded some data. And then with all of this being said, I decided to now get into the model training portion of the project. So now what I did was I added the original fares based on what was given in the previous slide, and then modify or add a column, if you will, to like show the fare prices based on what was given. And I wanted to kind of see like an optimization model that minimizes the fare prices but can maximize the revenue. I kind of wanted to treat this as a regression problem. And what I want to do is the models will be created for modeling vehicle volume. So in this case, we'll use Easy Pass. Could have done the same for the cash. And then some models that I will be using are like simple linear regression, elastic net, and random forest, using a 730 training test split. A little bit of the explanatory variables and response variable as mentioned. And then basically the metrics I wanted to use were like the root mean square error and the mean absolute error respectively. Whichever model had the smallest one is the one I would feel confident going with. Okay. All right, so a little bit of the metric results, some of the code that I ran. To get things started, I had to pretty much take every variable, convert it to one-hot encoding, since most of these models only take numerical data. And then in the next slide, I pretty much calculate the root mean squared error and the mean absolute error of each one. My random forest, I decided to do something like 100 trees. A lot of, number of estimators really can slow down your PC and really take a very long time. So since I felt time was of the essence and I wanted to turn this in, I decided to do 100 trees. I So what I did was compute the metrics. We kind of see that the random forest model felt like it performed the best in predicting vehicle volume, vehicle traffic for um, for the data that is given using the actual original fare prices. And then we see that, feature importance like the Plaza ID is very key and vital. The data is as well, which kind of makes sense. Your vehicle volume is basically mostly being governed by like where you are and what time. And then what I wanted to do next, as I mentioned earlier, and I thank Professor O'Connor for giving me this idea, was to kind of make simulated fares. So like start with like say $4 per toll and increase it by like little increments up to $20, let's say, and then run random forest models for each and every one to see how it will work. So then what I did was for each simulated fare price and then the forest model appended to a brand new column. And then what I want to do is basically graph and compare to see how the vehicle traffic would appear under the given criteria of a possible fare price. And then I just didn't get the chance to put it here, but I'm just gonna slide over my Python notebook. And when I do graph each of the fare prices per year for Plaza, I was a little like disappointed, a little down because they all mostly appear the same. So to me, that feels that like changing the fare prices really doesn't much matter in traffic congestion. I mean, over time, MTA is always increasing the fares, but yet in New York City, since that is such a very dependent way of commuting, people will still use it regardless, unless the MTA would charge such an extremely high value that it would make it, not adequate, for commuters to get to where they need to go. And then like some of the things I realized while running this is that maybe some things I want to consider, use a different data set, maybe use different features, use a different algorithm. I thought about doing like unsupervised learning and seeing if that would have worked, but I don't know, there's a thing called unsupervised regression. And then maybe include other factors like CO2 emissions, weather, vehicle type, and the model. So I guess this bread and butter like model or simple, model or estimation, for now, setting the simulated fare prices to a fixed value across all of them and doubling it for like the Verrazano Narrows Bridge kind of gives almost, little less, a little bit of more of traffic. So it's not much of a change in summary. And these are just a little bit of the references in the blogs I gave earlier. And yeah, that's pretty much it, this summary. And, thank you, Professor, for some of the advice you gave me.
Oh, you're most welcome.
And yeah, that's pretty much it. Sorry?
No, you're most welcome. It's interesting, interesting study. I wanted to ask, well, first of all, thank you, Andy, Julian, Mendy, for joining us. I just wanted to know first if any of you had any questions for Jonathan regarding his presentation or his methodology or anything you'd want to ask. Okay, well, I'll take that as a no. Well, actually, that's the only presentation we have. All the other presenters submitted their recorded video presentations. So why don't we just open it up to Andy, Julian, Mehdi, and any questions that you might have of me in our last session here. Andy.
No, I'm fine. I mean, I was just gonna ask, like, I have no questions. Yeah.
Ah, okay. All right, all right.
Yeah.
Okay. Well, I just want to say I've been just extremely impressed with the quality and sophistication of your papers. I hope I wasn't too much of a nudge in my edits, but I think just overall, I don't know, just been very impressed with the presentation. This was one of the better classes I've had, and I hope you all got a lot out of the course. I hope you are all very proud of your output. I think you should be. And if anyone doesn't have any further questions, I'll give the night back to you. One last shot. Anyone have any comments, questions, concerns, or anything they want to ask me about the course? All right, very well then. Thank you for joining the call. Thank you for taking the course in the interim. If you have any questions, please feel free to reach out to me. And
Thank you, Professor.
Yeah, thank you, Professor.
all right, you're very welcome. Have a great night.
You too.